Hi students, today I am going to explain what is isomerism. So what is isomerism? So the compounds which have same molecular formula. So the compounds will be having same molecular formula but structurally they are different. Means different structures they will form. So they are called isomers and the phenomenon is called isomerism. So the compounds in carbon compounds, so many compounds are there but they are having same molecular formula but they differ in their structure. They are called isomers and the phenomenon is called isomerism. There are different types of isomers, like two basic types of isomerism I took: structural or constitutional isomerism and stereoisomerism. Again, in structural or constitutional isomerism there are different types of structural isomerism. Let's see. So structural isomerism means they are having same molecular formula but different structures. So how they are having different structures, let's see. In structural isomerism, first one is chain isomerism. So the chain isomerism is, in this they are having same molecular formula but the structure how it is different because of the carbon atoms branching. So or chain length, the chain length will be different. So or the branching of carbon atoms will be different. For example, if we take pentane, pentane means 5 carbons will be there. So CH3, CH2, 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 CH3, 1, 2, 3, 4, 5. So if they are arranged in like this, so it is called normal pentane, but it may be branched. So one carbon atom may be branched with 2 carbon atoms like this. Then it is called isopentane. See, CH3 and the C, it is branched with 2 carbon atoms, CH3, CH3 and CH3. So 1, 2, 3, 4, 5. It is also a pentane because 5 carbons are there and it is isopentane. Like this, the carbon atoms, the chain length will be different. It is branched or normally arranged. Then next, after chain isomerism, positional isomerism. In this, it is having same molecular formula but how the structure differs because of the functional group position. So the functional group which is attached to it, it differs in that position. It may be in the first carbon atom, second carbon, third carbon. So the functional group attachment will be differing in their position. For example, one butene, see here butene. So double bond butene, CH3, CH2, CH, CH2. So 4 carbon atoms, butane. So because double bond is there, butene. So here double bond is in first position. So after first carbon atom, so it is 1 butene. And here 2 butene because after second carbon atom, double bond is there. So it is 2 butene. So the position is different in these two groups. So it is called positional isomerism. Next is functional isomerism. In this, the functional groups will be different. Here the functional group position is different. Here functional group itself is different. For example, here see ethyl alcohol. So CH3, CH3, OH. Here alcohol group is attached. Here dimethyl ether. So CH3, CH3O. Ether group is present. Here the same formula, molecular formula, CH3, CH2, OH. Here CH3, CH3. Here H is transferred. So from OH, H is transferred to this side. So it will become different functional groups. So it is dimethyl ether. Like this, the functional isomerism. And again in functional isomerism, again different special types are there. Let's see. So metamerism. What is metamerism? It is a special type of functional isomerism in which there is a RAR process. See, RAR structure. So where A is the heteroatom. So because it is having different alkyl chains on either side of functional group. So on either side of the functional group, different alkyl chains will be present. Here it is C2H5 and C2H5. Though both are same, ethoxy, ethane. Same molecular formula, again differently it is arranged. See here CH3O, CH2, CH2, CH3, propane it is. So 1 methoxy propane. So here the functional groups are different. So depending on the different types of alkyl chains attached to the functional group, this is metamerism. So CH3O CH3, CH3, CH3. Here to the first carbon atom O is attached. So functional group is attached. So 1 methoxypropane. Here for second carbon atom functional group is attached. So 2 methoxypropane. Like this metamerism. Next one more special type of functional isomerism is tautomerism. Here also same molecular formula, but structurally it is different because of the hydrogen atom which is wandering. It will not be one side, it will be changing its position of hydrogen atom in many polyvalent atoms. So let's see here CH3, CO, CH3 and hydrogen atom present here. It will go to the O and it will become OH and the double bond is broken and here it is formed. So it is enol form. So because of the wandering nature of hydrogen atom in the functional isomerism, so functional groups will change. So this is it is a functional isomerism, but it is a special type because of the wandering nature of hydrogen atom. So it is a keto form and it is enol form. That is tautomerism. Next, so far we saw about structural isomerism and chain isomerism we saw. Next is structural is over. Next is stereoisomerism. Let's see what is stereoisomerism. In these compounds, identical molecular and structural formula but differ only in arrangement of atoms or groups in space around the carbon. So around the carbon, the atoms or groups which are arranged will be different. The arrangement of the groups around the carbon atom is different. They are called stereoisomers and the phenomenon is called stereoisomerism. So again it is of two types, optical isomerism and geometrical isomerism. So what are optical isomers? It is a special arrangement of substituents, that is functional groups around the asymmetric carbon atom, and because of the plane polarized rate rotates in different directions, these substituents are arranged differently. So here see, so this side H is arranged. When we see the mirror image, we can see the OH is arranged this side. So these are called optical isomers. Optical means by seeing. So because of the plane polarized rate is rotating, so here we can see different substituents or different functional groups attached in different way. So this is optical isomers. Then one more is geometrical isomerism. Here in this same molecular formula, structural formula, but arrangement of groups in double bond. Here single bond of carbon atoms. Because of plane polarized rate, it will appear differently. But in here, C double bond C. So double bond between two carbon atoms. In this, the arrangement of groups is differ. So here see CHCl, CHCl. Here H is arranged. Two functional groups are same here. So it is called cis 1,2 dichloroethylene, and ethylene because of two carbon atoms and double bond is there. So here different groups are arranged. So here same HH CL on same side and different here HCl CLH. So trans 1,2 dichloroethylene. So these are the examples of isomers. Thank you.